Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 204. Count primes. Given an integer n, return the number of prime numbers that are strictly less than n. Okay, so they will be given a value n. We want to find what are the prime numbers that are less than that n value. Okay, now what is meant by prime number? A prime number is something which has two factors. One is 1 and another one is itself. Okay, so for first example 10, I can say this is the range, right, from 1 to 9. Okay, from this what are the prime numbers? I can say the prime numbers are, sorry, here comes 0 also. So here what are the prime numbers? The prime numbers are 2, 3, 5 and 7 because they all have only two factors, right? See here, this 2 has 1 and 2, 3 has 1 and 3, 5 has 1 and 5, 7 has 1 and 7. But apart from this, everything has more than one factors, right? Sorry, more than two factors, right? So that's the reason why these are called as what? Prime numbers, right? Now, how to find this prime numbers count? So see here, the basic brute force approach. The basic brute force approach to find these prime numbers is just go and iterate through this all values, okay, and then check whether how many factors are there for each and every numbers. If it is only 2, okay, then it is accepted and increase my count or add in my result. Okay, otherwise don't add in my result. That's it. So this is a brute force approach, and this brute force approach goes up to a O of n square and space will be O of 1. Okay, now whether we can optimize it. Yes, that's an optimal approach to find the prime numbers in an interval. What is that optimal approach? So see here, this is the optimal approach. First of all, I will demonstrate the optimal approach by using n is equal to 26. Okay, if n is equal to 26, then we want to find the prime numbers up to what? Up to 25, right? Okay, fine. First step is to construct array. Construct an array of size is equal to n. Okay, and assign every values as 1. 1 indicates what? Prime number. Okay, fine. Now what is the second step? Second step is to make 0 and first in this as what? 0, which means what? Not prime. Okay, so make this as 0, make this as 0. Fine. Now the third step is traverse ahead and change each and every multiples of the prime number as not prime. What it signifies? So see here, 2 is a prime number, right? So 2 multiples are not a prime. So go to this 4 and make this as 0. Go to this 6, make this as 0. Like that, 8 0, 10 0, 12 0, 14 0, 16 0, 18 0, 20 0, 22 0, 24 also 0. Fine. Now let us go to the next value. What is the next value? It is 3. Whether 3 is prime? Yes. So multiples are not prime. So go to the 6, already made as 0, and go to this 9, already, sorry, it is not made of 0, right? So make this 0. Now 12 is already 0, and then 15 make this as 0, 18 already 0, 21 make this as 0, 24 already 0. Okay, fine. Now go to this 4. 4 is what? Already not a prime. So don't worry. Go to this 5. 5 is what? Prime, which indicates what? It's multiple, it's not a prime. Okay, see here, for 5, 10 is already changed. Okay, go to this 15. 15 is also already changed. Go to this 20. 20 is also already changed. Go to this 25. 25 only we need to find. We need to change. Okay, take this into our consideration. Okay, now this 7 is already not a prime. Sorry, 6 is already not a prime. Now 7 is prime, right? So 14 is already changed and 21 also already changed. Okay, next prime number is what? 11. So come here. So 11 is 22. Multiple. First multiple is what? 22. 22 is also changed already. So see here, next one is what? 13. For 13, it is what? 26. Right? For 13 itself, it came to the 26. Then this 17 other prime numbers beyond 13 have greater value, right? But there is no such values in this array. So I can stop here. So just observe this carefully. Up to this 5, for each and every prime numbers, we just made their multiple as what? Not a prime. And when I reach this 7 and greater than 7, I can say there is no prime number, there is no prime number that is changed, right? For 7, 14 is already changed, 21 is also already changed. Like that for 11 also, for 13 also, for 17 also, there is nothing to change, right? So this is the first observation. The second observation is that, see here, when I am starting for this 2, where I changed first 4. When I am starting for this 3, 6 is already changed. So I changed what? Changed 9 at first. Okay. Now when I am changing for 5, what is the element that I first changed? It is 25. Because 15 already changed, 10 already changed, 20 is also already changed. So I gone to what? 25 directly. So from this observation, I can say we want to start from where? We want to start from that numbers square and need to change those multiples. Can you understand this? So how my code something looks like? My code something looks like, first of all, I iterate from where? From 2. From this 2. From 2 up to what? Square root of n. Okay, fine. Now, I want to check if this array of I is equal to 1. Which indicates what? Which indicates, hey, my current number is what? Prime number. Then its multiple won't be the prime number, right? So I will go to here and say, start from where? Start from its square, and move to where? Move to up to n. And how many times I want to jump? You need to jump I times. Because for 2, I go 4, then 6, then 8, then 10, then 12, etc. so on. Like that. Okay. Now, after going to this, I want to change those multiple values as what? Not a prime. So this is the whole set of code. Got it? Now, at last, now we can count what are the elements that are 1. What are the array elements that are 1? We will take this as our prime number count. That's it. So this is the optimal approach. What is the time and space complexity? Space complexity will be O of n, and time complexity will be what? O of n log of log n. So much optimized. So see here, this is the code. First of all, I am just checking if n is equal to 0 or 1. If it is so, I just return 0, right? Then what is our procedure? First of all, I want to take an array of size n with full of ones. Okay, so here they have given that it is strictly less than. That's why I'm taking what? N. Otherwise, we want to take what? N plus 1. Okay, now prime of 0 and prime of 1 will become what? 0, because they both are not a prime number. So I declare as 0. Now for I in range of 2 comma int of square root of n plus 1. So I'm just iterating from what? 2 to square root of n. That's what I told there also in drawing explanation. Now next step, if prime of I is equal to 1, then what should I do? I just go and just start from square of I and jump with I up to what? N. That's what I written here, and make those multiple as what? 0. Now C is equal to 0, and I am going to count what are the values in that array with value of 1. Okay, what are the in this with value of 1? Because they are what? They are the prime numbers. That's why. Then at last I am just returning the result. That's it. Let me submit it. Yes, it is submitted successfully. Thank you.